congestion avoidance mechanism we'll talk about is weighted random early detection. Now, the concept of weighted random early detection is exactly the same as random early detection what we discussed. So here also what we do is we configure some values, and as long as the traffic is within this minimum threshold limit, it's going to do no drop. And once it starts exceeding, it will start doing the random drop. Let's say anything in between 32 to 40, it will do random drop, and anything exceeding, it will do tail drop. Now, the only difference between the red and the random weighted red is here we are going to add weight to the random early detection. So which means we can configure based on precedence or DSCP values, and we can tell that if the traffic is coming with a precedence value of 1, then I can say that the minimum limit is 10, let's say the minimum threshold value, and for the maximum threshold value is 30. And if the precedence value is 5, I can say that the minimum threshold will be, let's say, 25, and the maximum is 30. So we can have a differentiated values of minimum threshold and the maximum threshold values for different marking values. So accordingly, it will work. So it is going to do selectively where the low priority traffic, nothing but the low marking traffic, will be dropped in case if there is any congestion, and automatically it is going to give priority for high priority traffic. So it will do random drop because it has to do random drop of if there is a congestion. But again, before the queue becomes full, it will do random drop based on the priority markings. So that's what the weighted random early detection will do. So in the case of weighted random early detection, we need to understand 3 values here. We'll configure, like we'll say minimum threshold value and the maximum threshold value, and we have something called mark probability denominator. Now first let's try to understand what is the minimum threshold value. Now the minimum threshold value indicates the minimum number of packets that must be queued. Like in this example, you can see I'm saying that if the precedence value is 0, the minimum packet size is 10. That's what I'm saying. So which means anything less than 10, there will be no drop for precedence value 0. And in case if the precedence value is 1, it can be 12, it can be 14, it can be 16. Like we can actually decide these values. We can configure based on different marking options. So same like the minimum threshold value, anything less than minimum threshold value means the package will be queued, and it will not drop any packets unless it goes beyond the limit. Okay, so once it goes above 10, like once it goes 15, then it will start doing the random drop. And that random drop is completely based on the marking the precedence value or the DSCP values. But anything less than that, that is what the minimum threshold. So there will be no drop. And there is something called maximum threshold. Now the maximum threshold means, now here, anything in between minimum to maximum. Like in this example, let's say if the precedence value is 0 and the number of packets waiting in the queue, let's say if it goes 20, which is in between 10 and 25, so it will start doing the random drop. So it will start the random drop. So this random drop happens as long as the packets are within this limit. As long as they are in between 10 to 25, it will do random dropping. And that is a maximum threshold, means up to 25, that is a max. So here 25 is just a number, we can change that. But anything in this range, it will start doing the random drop, and the random drop is done based on the marking. It's going to check the precedence value and the DSCP values. And again, in case of DSCP values, we have a drop probability bit, which can be a deciding factor for the packets, which will be more drop probability options that will be dropped. So once it reaches this limit, which means once it reaches 25, again it will do tail drop, because once it exceeds this limit, it will do tail drop from here onwards. So there is one more value here. We have something called mark probability denominator value. Now this value is going to tell the number of packets that will be dropped when the size of the queue is in between this range, means in between these two. Let's say if the queue size is 20, which is in between 10 and 25, so it's going to do random drop. But again, how many packets it is going to drop? So how many packets it's going to drop, that will be decided based on this MPD value. Like here you can see the MPD value is 5. So which means for the precedence value here, 0, the MPD value is 5, which means out of every 5 packets. So out of every 5 packets, there is a chance of each packet is getting dropped. So which means as per this value, it is like 20%. Means out of 5, 1 packet will be dropped. So if I give 10 here, which means out of 10, 1 packet will be dropped, which is 10%. So probably it is going to do random drop the 10% of the packets. The simple thing here, it simply says that it's doing random drop in between this. When it is doing random drop, what will be the ratio or the percentage of the packets to be dropped? Like here you can see 1 by MPD means 1 by 5, means out of 5 packets, 1 packet will be dropped. So that's how, if I say 1 by 10, if I give 10 value, it means out of 10 packets, 1 packet will be dropped. That is what random drop happens based on this MPD denominator values. So this example again gives a clear idea like how exactly these values are given, and based on these values, anything in between the minimum to maximum threshold value, it will do random drop, and anything in between 0 to within less than this, there will be no drop, and anything exceeding this, it will do tail drop. And what is the ratio of the packets will be dropped, that will be depends upon the MPD value what you configure. So that's how the random error detection is done. So the only difference between the random error detection and the weighted random error detection which we use is the weight will be added, and the packets, and when it is doing random drop, it's going to decide based on the marking or the weight values.